Vanakkam. Today we are going to see differentiability chain rule. So what is the differentiation for composite functions? Let f be a real valued function which is a composite of two functions. F is equal to v composite u. Suppose t equal to u of x and both dt by dx and dv by dt exist, then we have df by dx is equal to dv by dt into dt by dx. This is the chain rule. So what is given? We can write this f as v of u of x, and we are taking this u of x as t. So see here, f is a function of v, v is a function of t, t is a function of x. So the differentiation is df by dx is equal to dv, since v is a function of t, dv with respect to t, and t is a function of x into dt with respect to x. So this is the definition of this chain rule. Okay, now here we have f as a composite of two functions. Suppose f is a real valued function which is a composite of three functions, then what about the chain rule? So here f is equal to w composite u composite v, then we have to find. Now if you write this function, we can write this as f is equal to w composite u, okay, of v of x. Now it is equal to w of u of v of x. Now if you see here, let me take t is equal to v of x, then we can write this as w of u of t. Now if we take s is equal to u of t, we can write this as f as w of s. Now if you see the differentiation, df by dx, dw, since w is a function of s, dw by ds into ds, s is a function of t, ds by dt, and t is a function of x, dt by dx. So this is the chain rule. The definition is here, df by dx is equal to dw by ds into ds by dt into dt by dx. So this is simply the explanation of this differentiation of composite of three functions. So now let me see some problems based on these composite functions. So the first problem is, find the derivative of the function given by f of x equal to sin x square. So here we are having the function f of x equal to sin x square. So this x square is a polynomial function and a trigonometric function, that is a composition of a polynomial and trigonometric function. Therefore here I can write this function as, I am going to take t is equal to u of x, which is equal to the polynomial function x square, and v is equal to, v is a function of t which is equal to sin of t. From the definition here I am taking t is a function of x and v is a function of t. So here t is equal to x square and v is equal to sin of t, v of t equal to sin of t. Now by the definition, we have that for the composition function f is equal to v composite u of x. We can write this as df by dx is, according to chain rule, it is dv by dt into dt by dx. Now, what is dv by dt? What is the differentiation of v with respect to t? Which is equal to the differentiation of sin t is cos t, and what is dt with respect to x? That is differentiation of x square with respect to x. So the differentiation of x square is 2x. So when we apply here, we are getting df by dx is equal to dv by dt, that is cos t into 2x, but we have t is equal to x square, therefore we can write this as 2x cos x square. So this is a very simple problem based on composite functions. Now the second question is differentiate sine of cos of x square with respect to x. Now this is the function x sine of cos x square, which is the composite of three functions. Let me write f is equal to sine of cos x square. So by the definition, let me write the definition first. We already saw the composite of three function. F is equal to w composite u composite v, w composite u composite v of x. Again I am telling w composite u of v of x. So I am going to take t is equal to v of x. So we can write this as w of u of t, and I am going to take s is equal to u of t, therefore f is equal to w of s. So if you compare these things with this problem, I am going to take w of s, which is the outermost function. I am going to write this as sin s, and s is equal to cos of t, and t is equal to x square. So by the chain rule, df by dx is equal to, so f is a function of s, therefore df by ds, and s is the function of t, therefore ds by dt into t is a function of s in dt by dx. Now what is df by ds? Df by ds, which is equal to differentiation of cos s is differentiation of sin s with respect to s is cos s, and ds by dt is, that is differentiation of s with respect to t, differentiation of cos t is minus sin t, and dt by dx, that is differentiation of t with respect to x is 2x. Therefore we can write this df by dx as df by ds, which is cos s into minus sin t into 2x. Now which is equal to, since s is equal to cos of s, that is cos t is equal to x square into minus sine of t is x square into 2x. Therefore, we can write this as 2x minus 2x cos of cos x square into sine x square. This is the answer for this problem. Now the next problem is find the differentiation of f of x equal to secant of tan root x. Now, so here let me copy this. See the same thing, the composite of three functions, secant of tan of root x. Now the same, w composite, u composite, v of x. Now see here, the innermost function is root x, therefore I am going to write t is equal to root x, and the next outer is s is equal to tan t, and w of s is equal to secant of s. Now by the chain rule, differentiate, that is here the composition is f is equal to w composite u composite v of x, and the by chain rule df by dx is equal to f is a function of s, therefore df by ds, and s is a function of u of t, that is a function of t, therefore differentiation of s with respect to t, and t is a function of x. Now what is df by ds? That is differentiation of f with respect to s first. That is, what is the differentiation of secant x? What's the differentiation of secant x? We already studied the formula secant s tan s, and differentiation of s with respect to t, that is differentiation of tan t is secant square t, and differentiation of t with respect to x, that is differentiation of root x with respect to x, that is 1 by 2 root x. Now we are going to substitute all the things in the chain rule, that is df by ds, that is secant s tan s, and ds by dt is secant square t, and the third one is dt by dx 1 by 2 root x. Now we know that t is equal to, and what is s? S is equal to tan t, therefore secant of tan t, what is t? T is root x, t is root x, and this is secant of s, then tan of s, s is equal to tan t, t is equal to root x, then secant square t, t is equal to root x, and 1 by 2 root x. So this is a very simple problem based on these composite functions by using chain rule.